In a climate-controlled vault deep in the bowels of Vanderbilt University lives a population of Anopheles mosquitoes. Anopheles are responsible for about 1 million malaria deaths globally each year, but Dr. Patrick Jones and his colleagues believe they might just have found not only a scientific solution to the malaria scourge, but a great deal more, purely by accident.
When we started out, we sought to develop a new mosquito-specific insect repellent. But along the way, what we think we've discovered is a compound that has the potential to repel virtually all insects. So this would be the nuisance insects in your backyard, disease vectors, as well as agricultural pests.
With a grant from the Bill and Melinda Gates Foundation, Jones was studying the mosquito's olfactory system, which it uses to detect humans whose blood it favours over other mammals. He would remove and crush the insect's antennae, where the smell receptors are housed, then bombard them with more than 117,000 different chemical compounds to see if any affected the individual receptor cells. One of them did. The compound is called VUAA1.
So essentially what this compound does is it activates every single smell receptor that a mosquito has, thus doing two things. It'll short circuit their their olfactory system, but at the same time it'll also mask their ability to smell anything else.
And if the mosquito can't isolate the smell of a human, it won't be drawn to humans as a food source. Biological science professor Lawrence Zweibel is now fielding calls from private industry about developing the compound for use in anti-malarial products like aerosol sprays or bed nets impregnated with the compound in a liquid form.
This opens up an opportunity to really design a new class of chemical compounds around this active lead that we've found to perhaps reduce toxicity concerns that have been plaguing current spate of commercial repellents, to increase the efficacy of these things, make them work at much, much lower concentrations, and ultimately to provide more access to these compounds, which have a high cost as it currently stands and are outside just the pocketbook of so many people around the world.
It was an accident and it was fantastic. It was something we didn't expect, but we're so happy we found it, and hopefully, someday that this can be used to reduce malaria transmission in Africa, which is our ultimate goal.
Vanderbilt University has filed for a patent on the newly discovered compound, and while commercial development will take millions of dollars and years of further testing, a truly effective repellent for malaria, dengue fever and other mosquito-borne diseases is now a real possibility. Rob Muir, Reuters.